Okay. This video is about this device. Has a lot of things, interesting things. I have another one that's doing transcoding and running a bunch of storing my repositories and stuff. Right now, what I'm doing is trying to put most of my stuff onto OpenBSD or Unix. Linux is getting too messy, too chaotic, not so stable, and too big. And there are main differences between Unix flavors, specifically OpenBSD, that makes it interesting. For starters, is extremely small. The kernel is really small. The way they work is really small. They're really prone to open source, which is something that I really like and believe in. Their code is solid, and they're known for that. And so the whole thing started actually with an email. This one here. I eventually got something that got my way. I actually ended up not. Maybe this. I should have tried this one. Now that I think of it, but okay. So DTB is a device tree blob or binary. It essentially tells the kernel what kind of device it is and what things it expects to see. Now, embedded devices are really different from the other type of devices that we have, namely a regular Intel or x86 architecture, where you have firmware that you interact with, and then that usually leads into letting you know what you have and whatnot. In this case, you don't. Okay, you have a file, and now if this file is wrong, well, you're going to see. Now, usually this ends up with, hey, success. But it's actually not actually the case. This board is not officially supported, although there is a DTB file on the OpenBSD. It's in the fringe of the supported device. It's actually not even mentioned in this list. There's a close parent of the device here, but none of the devices that the vendor says that this device inherits from is in this list. And there's a closer parent, but even in the vendors DTS, which is the device tree sources, they have a different file and don't inherit much. So there are clear differences in those. So after that, and if you're curious, I'm a massive spoiler. I'm the kind that sees the end of the movies first when I can. So I'm currently working on it. So I'm recording this as a saga. So the details as follows. I was able to actually make this thing boot. It's basically a chain loading. The way this runs is you have flash with a small binary. That binary is responsible for loading the second loader, which is the U-boot. And in case of Linux, the U-boot will pass along the DTB, which the kernel is going to load, and it's bulky as hell. It's really big. It's 9 megs. And tells everything it needs to know about the device, and so it basically magically works. On OpenBSD, things are a bit different. Okay. Instead of using the U-boot's device tree file, what it does is it uses only the minimum amount of information from it to find one that it trusts internally. And so this means that their file is actually, in comparison, really small in comparison. Actually, it's only K. Since one is 9 megs, the other one is like 78K or something. It is true that they are really different. They have less stuff in it. So, while testing this thing, and the device in question has 32 gigs of memory, has 8 cores, I managed to basically do the chain loading, which is what we're going to see next. And it has a very weird baud rate, which I manipulated initially. Weirdly, I may add. But still, you're going to see. Whatever or not is actually an issue, or my very hackety UART cable may not be the best option. Okay, but regardless of that, and eventually it stalls. It stalls right on here. There is some backtraces and a few attempts that I made in order to see if I could get around it, to pinpoint the issue in question. And doing this and disabling some of the stuff that I suspected might be an issue with it. And culminated with what I think might be it hard here. So the vendor has two different DTBs, one for the regular and the one for the plus. There's some differences around the clock names, the main power handles, explicit reset lines, power wiring, and some of those things. Some of these things are stripped on the OpenBSD one because some of the devices are not going to be used, or there are not drivers for it, or a combination of those, or they're just disabled. This is meant to be something like purely for storage on this case, so I'm not really worried about not having HDMI or something like that. I really wanted to see this thing boot. So this is the current state. It's an email went out this morning, what you're going to see next is me playing around with it. I hope you enjoyed it. Enjoy it. It is a change because usually my office is a bit organized. Along were the times where this looked like an organized chaos. But it's been a very interesting set of days. Now I plan to do this kind of stuff more often. I just don't have the time. If I bricked it, it's 300 euros down the drain. Let's hope not. I definitely didn't buy this for the video because I'm actually really interested in bringing this device over to OpenBSD. So I hope you enjoyed it. Stay frosty, and I'll see you on the next one. Oh, just keep going. Keep going. There's more. Okay, so I decided to do a bit of voiceover here. Okay, so here's the deal. We're going to need a few things. So starting with the OpenBSD's repositories, we're going to download two files here. We're going to need to go through the 788, go to ORM, which is there. Then we're going to need the mini root, and we're going to need the install notes. Okay, that's a list of supported files. Now, and some of the instructions on how to play with this stuff. Now, essentially what's going to happen is we're going to need to do a chain loading. So we're going to need to do basically the root operating system file system, or the mini root OS, let's say, and we're going to need a build of the U-boot, so that we can then chain load it with the EFI. So just basically we need one U-boot capable of loading EFI. Okay. Otherwise, it would be a bit tough to get this thing to work. Now in here I have basically everything laid out already. What's been going for a while. Now, in case you're curious, you're going to see the wiring of it. As you saw the wiring, actually, I saw the wiring there. I'm using a Flipper Zero at this point as a UART bridge with a very crude cabling setup. And so, first things first, we need to put the mini root file system onto the device. Now on OpenBSD, actually Mac also has this, but the name of this device has changed. So if you want to use the raw device, you do an R at the back of it, and then there's a C after the number of the device. Okay, I say I'm 1 week into OpenBSD. I've used BSDs in the past, but it's OpenBSD is the first time. So I'm actually having loads of fun. So BS1 is to keep this thing a bit faster, and it's going to take a few seconds to get it to run. Okay, and eventually we're going to use something that in Portuguese actually has a very cool name. It's an application called Ku. So I can't say this straight. Just Google it. This the escape is acting out because I'm actually using a Mac keyboard, so I had to use the capital E. And then from dmask, you get the device where the Flipper Zero UART bridge is going to show up on OpenBSD. And so that very long string USB dot one dot yada yada yada. Now another thing that we're going to need is the first, actually in the device itself is going to be the second one, the second loader to be loaded, because there is something in the flash that starts the system, and where I think I got in trouble yesterday. So we're going to need this here, and this is where things start to get a bit interesting, because I'm using a closer parent U-boot in this case, because it's also from the same vendor, but it's a different device. So this device, if I'm recalling correctly, it inherits from the Nano PI M6, and in case of the OpenBSD, the closest parent, it's not that device. That device is actually not on that list. So I ended up choosing the closest device I could get from the same vendor. And the idea is to see, well, if the thing booted in the first place, would be a cool win, and then take from there, because it's the first time I'm doing this for any OS other than Linux, and usually doing this with Linux is actually fairly easy. So after this here, this is run, this has been running, I'm going to go back onto the device, and you're going to see my new and very crude cabling. Okay, now we're going to switch back here, and we're going to start with a very big bolt rate. That's the default from the board. It's going to take a bit, is you need to press a few buttons and put it into what's called mask mode, and for it to start to load, to try to load things from the SD card. It takes a bit, but eventually it starts. Yeah, there it goes. Okay, after this, it means that the build rate changed. Okay, so we're going to basically do that change. Now, I don't yet know every single shortcut from Ku. And so I'm going to do this by hand, by doing this the lame way, which is to terminate the thing and change the build rate. Okay, I would reckon that there's actually a shortcut that I'm not yet aware of, but I'm only using this for a week, so. Okay, so the thing goes, and eventually it does. Now I'm using Flipper 0, changing boot rates mid session with it is it doesn't always go as smooth as one expects. That's basically it. That's where I'm at right now. Hope you enjoyed it. Stay tuned. Hopefully I'll be successful at bringing this thing up with the help with the rest of the OpenBSD gang.